Hello, I'm Bukola Joseph, the physics enthusiast. So I want to teach you how to perform experiment on reflection using the theoretical perspective, okay, without having to perform the experiment. So the first thing we need to do is to hold the paper down with thumb pins. We have a thumb pins. This is a thumb pins. This is a thumb pins. The next thing, the mirror you have to use, measure it with your ruler. So if you measure with ruler, I measure this and I have 10 centimeter. So the 10 centimeter, I will measure it on my plane sheet. Okay, so of course this is 10 centimeter. So you share this 10 centimeter into two, you have 5. So I'll put a dot on 5 where I will draw my normal. So I'm going to be drawing the normal here. This is the normal. This is the normal. Waist going through the given sketch. So this is the sketch. We have normal. I'm going to label it just like we have on the original question. So the next thing you will do is to put your shades on your mirror, the silver lining. After that, according to what we have here, we'll draw a straight line, ZT. So I'm going to be drawing my straight line ZT. So we have ZT. This is my ZT. Okay, I will draw it, I will extend it a little bit backwards. So we have this. So this is T and this is Z. Okay, and then we have our M here, just like what we have in the question. This is M, this is M, so I'm labeling it M. So now we have this. So we are going to set our angle of incident I to be 30 degrees. Okay. So to do this, you are going to measure from the normal 30 degrees. You put your protractor like this. You make sure that this line is on the normal. This line is on the normal. So we'll count 30 from here. So we have 10, 20, and then we have 30. Then you put your pencil mark there. Okay, then you join this point and this point to get your 30 for incidence ray. So we have this, we join this point, so we have this. Okay, so this is the incident ray. Of course, this is what we call the angle of what? Incidence. And by law, angle of incidence is equal to angle of reflection. So it means the angle of reflection is going to be between 30, but because of, nobody's perfect, let's make it 31, 10, 20, 30. Let's add an inch to it. This is 30. Let's add an inch. Let's put 31. So you put a point. Let's join it together. So we're going to join these points and this point, this point, and this point together. And then we have our reflected ray. Okay? So, of course, use your optical pin to put your pinholes. We have P1, P2, P3, and then P4. Okay? So we have P1, P2, P3, P4. So according to the question, we are expected to extend this stem backwards, okay, to ZT. So we are going to extend this reflected ray backwards. Let's do this. We'll extend it backwards. If we do this, we have this. Right. So we have from the question we have R, this will be R, and then this is our Q. Okay, so we have I 30°. We are to measure Q in degree, and then we are to measure QR in centimeter. So what is Q? Q from the question, angle Q is this angle, all right? And then RQ is this distance from this point to this point. So let's measure RQ with our protractor. So if you want to measure RQ with the protractor, you put your protractor facing this direction. Make sure this point, the hole on your protractor, is coinciding with the point where they meet. And the line here is on 90, okay? So we are going to read from 90 to where we have this line. So we have 10, right? 10, 20, and then we have 30. I think it's 30. So it means Q is equal to what? 30 degrees. Okay? Then we are going to measure RQ with our meter rule. From here to here. So this is it. From this point to this point, we have 16.8. So we have 16.8 centimeter. So we do for the next, and then the next, and the next. So the next one is 35 degrees. So we'll do the same thing. We'll repeat the procedure again, like we've done before. We are going to measure 30 degrees. I'm not seeing. We are going to measure 30 degrees. From the normal again. So we have 10, right? 20, 30. This is 35. Put a point there. We connect it. Connect it to this point. So we have this and this. We connect it to this point. So the incident ray is going to be 35, around 35 too. So we measure that. So we have 10, 20, 30. So let me add this point, 35. So we are going to put this to this point and this point we just marked to connect it. Okay, remember they asked us to connect it backwards, so we'll do that. So if we connect it back, you have something like this. So let's label this R1, Q2, R2, Q2. Okay, so let's not forget an important. Put your pinhole, put your pinhole, put your pinhole, put your pinhole. We don't have to label again. Yeah, I promise you don't have to. So let's take our reading for Q, which is this angle. So to do this, we just put our protractor on this line again. Let's measure. We have 10, 20, 30, I think it's 35. 35. Good. So the next thing we're going to measure is QR. That's from here, QR from here to here. Let's measure that distance. So we have this distance. This is 13. This is 14. Is it up to 14? I think it's on 14. This is 14. So we have 14.0. So we'll repeat the same thing for angle 40. We're done with 35. Let's do for 40 degrees. So for 40 degrees, we do the same thing. We'll find the angle of incidence. 40 from the normal. From the normal. So we'll count. 10, 20, 30, 40 is here. We'll mark it and then connect it to O. So we're going to connect this point to O. So we have this. We're connecting it to O. Yeah, the arrow. Without the arrow, it's not a ray. So it's important you add the arrow. Okay? So let's do for the reflection. Using the principle, the law of reflection. So it's still going to be around this 40, okay? It should be around the 40. So we have 10, 20, 30, 40. I don't know if I pasted my... So 10, 20, 30, 40. This is 40, okay? So you can add 1 point to make it like real, right? Because mistake is inevitable. You can only minimize it. So we have this point. We have connected this point. Remember, we are tracing it back. So let's trace it back to touch QR. So make sure your line is on a straight line with the reflected ray backwards. So if you connect this line backwards, we'll have this. Okay? So this is our reflected ray. Let's label it. Then let's call this R3 and let's call this QR, right? We'll do the same thing. Let's measure QR again. Let's measure Q, angle Q. So angle Q, protractor. Angle Q will be this. We're going to be measure. Make sure this point where the meet is aligning with the hole in the middle of your protractor. And then this your 90, the line on 90 is aligning also with that straight line you are seeing there. Okay, so we'll count now. We have 10, 20, 30, 40. So we have 40. We'll measure Q to be what? 40 degrees again. Then the next thing we're going to do is to measure QR. RQ. So from this point to this point, sorry, I'm using the wrong side of the ruler. We have this. We measure from here to here. We have 12 centimeters. Then we'll do the next one. The next one is what? For 45. So let's measure 45. Okay, we're repeating the procedure again. We'll measure on 45 from the normal. So we have this is 10, 20. I mean, we know this is 40 already. So we are just adding 5 to 40. This is this. So let's connect it. So if we connect this point and this point, we have this. Remember to put your this. Always put your pinholes so that you don't forget. Put it so that you don't forget. Okay? So let's measure the reflected angle. According to the law of refraction, it should be equal. So we are just going theoretical method. We are using theoretical method. Remember, I'm not performing this experiment. I'm only going by the theoretical principle. So 10, 20, 30, 40, 45. Let me add small. Maybe 47, of course. So we have this, this, connecting this to O. If we connect this to O, we have this. Okay, so we're tracing this backwards. If we trace this backwards, we have this. So this is the reflected ray we have. This is going to be R4, this is going to be Q4. Right? So what are we going to measure now? We are measuring Q. So if we measure Q, if you measure Q, we have 10, 20, 30, 45. So we have 45. Well done. So let's measure RQ. If we measure RQ from this point to this point, we have 9.8. So we have 9.8. And finally, 50 degrees. Let's do for 50 degrees. So we'll measure the angle of incidence to be 50 degrees. So we have 10. Okay, we know this is 45. Let's just add 5 to it. Yeah. So we have this. Connect these 2 points together. So let's do for reflected ray. The reflected ray . 10, 20, 30, 40, 50. No. 10, 20, 30, 40, 50. Let me add small. So let's trace it backward. I've traced it backward. Let's put our arrowhead. Then we have R5, Q5. Do I really need to measure this again? I know it's going to give me 50. Then let's measure RQ. RQ is equal to 8.3. So this is the reading that we have. But if you were to perform this experiment yourself, you need a mirror. This is a mirror, a plain mirror. You first draw this mirror, the outline, and then you draw the incident ray equal to 30 degrees like I've done before. Then afterwards, you put the mirror and then back to the outline, okay, and then you put this pin here, then look in the mirror and put another pin in front of the mirror in front of the pin you are seeing in the mirror. Okay, so that is how the experiment is being performed. I hope you enjoyed today's class. Before we do that, if you check out the reading, if you make mistake, you would know. Look at this incident ray. As the incident ray is increasing, Q is equal to I, and then QR is what? Decreasing. I'm Sibukola Joseph, the physics enthusiast. Bye.